In this problem, we're finding the total translational kinetic energy of a liter of oxygen gas held at a temperature of 0 Celsius and a pressure of 1 atmosphere. Okay, so let me see. My pressure is 1 atmosphere, so let's first write what we have, right? So my pressure is 1 atm, so I got to be in base units, right? So I'm going to say that's 101,500 times my 1 atmosphere, right? I'm just doing this as an example. Mine was easy because it was 1. If you had like 2 atmospheres, then I'd put 2 here. And that would give me my pascals, 101,500 pascals. Okay. My temperature is 0 degrees Celsius. So 0 degrees Celsius, I have to add 273 to turn it into Kelvin. So that's 273 kelvins. And then my volume is 1 liter. So 1 liter, liters to cubic meters is 3 decimal places, right? So 1,000 liters equals 1 cubic meter. It's like converting from grams to kilograms, right? Or the other way around. It's 3 decimal places. Yeah, grams to kilograms. So 1 liter is going to be 0.001, right? 1, 2, 3, 1 cubic meter. So now I have PV and T. And you can see where this is going. I have PV and T. I need to use the ideal gas law, right? So you got 2 steps here. So first, you got to find the number of moles, right? Because I need the translational kinetic energy, right? And translational kinetic energy, internal energy, right? I'm trying to find the energy of the molecules. It's going to be 1.5 nRT, right? So I'm using 1.5 nRT, but to solve this equation, right? R is the gas constant, T is the temperature. I need N, right? So first I'm going to have to use PV equals nRT to solve for N, and then I can solve for the energy, right? So to find N, I can say PV equals nRT, PivNert, right? So you solve for N, I can divide over RT, so N equals PV over RT. And R doesn't tell you on here, R is the universal gas constant. In base units, it's 8.31. Right, so 8.31, my temperature is 273, my pressure is 101,500, my volume is 0.001, I can solve for N. And then once I know N, I can take N, come over here, put it in there, and I know my RT, I just basically solve this, right? And then I can get the internal energy, which is the same thing as the translational kinetic energy, right? Because internal energy is the molecules moving around with kinetic energy. So that's what you're solving for.